Hello and welcome to this unit, Unit E, where we look at running SQL over any kind of data that you have out there using Apache Drill. And we'll also take a look at running SQL within Spark as well. So it's a big unit on SQL. I know you all know SQL very well, but we're going to be taking a new take on it, which is how do you use SQL when you don't set up any schema at all? So let's get into it. So here's our agenda. We'll talk about, the basics of big data, where we came from and where we're going, how you can run SQL over unstructured data without setting up a table, how Drill works, how Apache Drill does what it does, what a storage provider is and how a storage provider works to give you a connection to a source of data that Drill can query. We'll talk about the nuances and idiosyncrasies of Drill SQL. And then we will close the books on Spark by looking at Spark SQL. And that will conclude our Spark journey, where we started with Spark over Hive. And then we looked at Spark's data frames, and then we'll finish with Spark SQL. All right. Let's start with taking a little history lesson on where we came from, data warehouses, into the Hadoop data lake world, and then on to sort of the world that we're in now, where we have what are called serverless data warehouses. So as you may recall, a data warehouse traditionally has been relational, and organizations use relational databases for BI, business intelligence, and data analytics. And the data in the data warehouse was heavily cleaned and transformed. It had to be packaged up before it could be consumed. And this was an extremely arduous and laborious and time-consuming process. And you have to take it from me, because I used to do this for a living. And you would take this data from traditionally what was relational sources, like you had orders and customers and products, and you would apply some pretty heavy-duty transformations to introduce things like data cleansing, data quality screening checks, introducing time variance into your data, and then that data would sit at rest in your data warehouse, and then that data warehouse would be ad hoc queried with SQL so that you can get what are called retrospective analytics. Who did what, and when did they do it, and what? And in some cases, why did they do it? So this is the world of the data mart, and it's a world where we try to build cubes and star schemas and things like that. And the reason that we have the cubes and the star schemas is it makes it easier for people to do analytics. With the I would say introduction of Hadoop, what we gained from Hadoop was the ability to do data warehouses like this at scale. As we saw when we did the Hadoop lesson, modern data is complex, comes in a variety of sources. It's not all relational, and the volumes can be incredibly large. So this is where Hadoop ended up shining. We created new data warehouses that look something like this. You would have your traditional data warehouse where you would still be doing your heavy ETL transformations on your products and your customers and orders. And then you would have these new sources of data, like what people are doing on your websites, what are they saying about your products on social media, how are they reviewing or evaluating your products through various sources. That information will all be collected and socked away in a data lake. And then somehow you get this data lake and this data warehouse to talk to each other. Usually you could use a tool like Hive to do that, because Hive will let you run queries over the data lake, and then you can also use Hive to connect it to a relational database. And then that way you can have your joins and things like that and connect stuff together. And move my head out of the way. And you can answer all sorts of questions like who bought what, when was it bought, what were they talking about, did they actually purchase it? Like if they review it, right, you purchase it here in orders, you review it here. This is one system, this is another system, but you can do what's called the verified purchase. You've probably seen this in Amazon, where you have knowledge that the person actually made the purchase who's doing the review. So this was the next evolution. It was exciting. You can certainly do this 100% in relational if your data weren't big enough. But many organizations that were really ahead of the data analytics curve, they really embraced using Hadoop to do this because of the sheer volume of data that you would get, the number of touch points you'd get over social media and weblogs. Okay, so where does that take us? Well, the next evolution of this is the server data warehouse. And in the server data warehouse, we have this large upfront investment. And this makes Hadoop kind of costly and impractical for all but the largest of use cases. So you are someone that wants to take advantage of all this unstructured data like weblogs and social media or reviews, but you don't have the expertise, the money, and the time to do Hadoop. So are you just out of luck? No, you're not out of luck. You can use instead the serverless architecture that you see here. And what the serverless architecture gives you is the agility to query data from anywhere. And this was so important with the adoption of cloud, because when you, for example, maybe adopt Amazon's cloud, you have access to the weblogs because your website's in Amazon, right? And you just want to query the weblogs where they are. You don't want to spend all this time moving the weblogs all around, putting them in your data warehouse, things like that. So tools were created that allow us to not only query the relational database, but we can also connect to our object store, our S3. We can also connect over HTTP to connect to social media APIs and query those APIs directly. We can also read from files in a variety of formats, and this gives us a lot of flexibility. And we got to use the same SQL that everybody knows and loves, and the same tools that everybody likes to use for their analytics, whether it's, Power BI or Tableau or just plain old Excel. All of those things were available for us to use to sort of do these queries. And this is something that you'll see as we go through it and sort of evolve and learn what this whole NoSQL / query anything you want with SQL movement is all about. So what do we mean when we say direct SQL query right here? Well, what we're talking about is we're talking about being able to query any source with SQL. And when we say any source, we really mean any source. We're saying it could be in Hadoop, in object storage, in local files. It could be an HTTP REST API. The files can be in a variety of formats. Some are not structured at all, like text. Some are semi-structured, like CSV. Some are very heavily structured, like JSON, and some are completely structured, like Parquet and Orc. But you can also read databases. So you can read relational databases, NoSQL databases, streaming databases, document databases, graph databases. You can read a lot of different types of NoSQL databases. And this gives us a universal way to query anything with a tool that we're familiar with, SQL, in spite of the fact that the database that we want to query maybe doesn't support SQL. And not only that, but we can take, for example, a JSON file, tabularize that, then join it to a relational table, and then join that to maybe data that we pull from a graph database. And so this is the real charm and allure of using these direct SQL query tools. They're big in the cloud. AWS Athena and Google BigQuery are the key players in direct SQL query. They allow you to store your data basically in object storage and just query it. They also include connectors that talk back to databases as well. You can also do this in a self-hosted / open source world using Apache Drill or Presto, which is kind of like the next evolution of this in the open source world. In the class, we will use Drill because Drill's pretty stable. It's pretty well known, and you've used one SQL direct query tool. You've kind of used them all, let's be honest. Their magic is not in the SQL itself. It's in their architecture, and we don't really fuddle around with the architecture at all. We just really kind of use it like a tool. I'll put myself back on the screen. There we go. All right, so let's take a dive into Apache Drill, which lets us run direct SQL over whatever the heck we want. So here's the website for Drill. Got a lot of great info on it. It's based on Google's Dremel system, which is the system that powers Bigtable. And it can be best described as an open source SQL query engine for big data. And it is architected in what's called MPP. So if you took the data warehouse class, you know we talked about MPP before. MPP stands for massive parallel processing. And this is a technique where we've also seen this. This is kind of how Hive works. It's a technique where we figure out a way to run our SQL queries in parallel over data that is distributed. It's actually kind of the same thing that Spark SQL does. Spark SQL is an MPP in a lot of ways. So the Drill SQL you write is very SQL compliant. It supports the SQL 2003 standard, and basically this standard has common table expressions and window functions in it. Those are the big things that were added there. So you get to take advantage of some decently modern SQL as you go ahead and use Apache Drill. The queries can come from a large variety of sources, and these are based on what are called storage plugins. And the storage plugins, if they're file-based, you can configure a variety of file formats. So not only can you talk to HDFS, but you can talk to Parquet on HDFS, or CSV on HDFS, or Parquet on S3, or JSON on S3. So you have so many options with Drill. That's the good part. The bad part is you got to configure it all. And so configuring it can be a little tricky. Once you get it configured, it's pretty trivial to use. So why do people like Drill? Why would it be used? Well, you can query the data wherever it is. There's no need to move it. There's no need to transform it. As a matter of fact, you can query a web service. So imagine you have a weather web service and it returns back JSON data. You can actually direct query that with Drill and show the output in a table format in your browser. It does schema on read. There's no need to actually predefine a schema at all. So unlike Hive, you don't even have to specify a schema. It takes an educated guess as to what your schema is. Now, if you're reading a database, like you're reading MongoDB or you're reading, Postgres or Microsoft SQL Server, it's going to have a schema. But for situations where there isn't a schema, like you're reading a CSV file, it will try its best to apply a schema to the data. It's incredibly scalable, so we will run Drill in single node mode, but it can also be run in a Drill farm where you have several nodes that participate, and when the data is loaded into Drill, it's spread across the nodes in the Drill farm, so it can take advantage of the parallel architecture. And it has a pretty high efficient query optimizer that, when possible, pushes the filter operations down to the source. So a good example of that is you might use Drill to query data out of Cassandra, and you have a where clause in there, and it will push that where clause into Cassandra and then have Cassandra filter the data and only bring back to Drill what needs to be brought back. Now, you don't really get this optimization when you're querying an S3 bucket or something like that, but you can get that optimization out of database management systems. So, querying Microsoft SQL Server, it will take that where clause in Drill and pass it right through to the DBMS to do the filtering for you. And this greatly eliminates the number of rows and columns that are returned from the query. What makes Drill so neat is it also supports ODBC, which is Open Database Connectivity. There's a driver for it, an ODBC driver, and this will allow you to connect Drill to your BI applications like your Tableau, your Excel, or Power BI. We'll demo this. So let's talk about appropriate use cases for Drill. So one really good use case for this is you got to read and write data in a variety of locations and formats. You want to quickly and easily run SQL over that stuff without having to load it into a table and create a table or even create an external table. You don't have to do any of that. You just point it at it and go. And that's what makes it great. So you can build analytics from polyglot sources and leave the data where it is. You don't have to move it around. It takes the E and the L out of ETL. You just do the T. Think about it that way, right? You're not moving data from one place to another. You're leaving it where it is. And again, it works with analytics tools. And what's neat is you can do little tricks in drill for performance purposes. Like, for example, you can join a table from S3 to a table from Cassandra to a table in a relational database, get an output that's a table, and then persist that somewhere else so that when other people query it, they're not going back and touching those sources again. They're just using the output. So that ends up, you can materialize a lot of data to increase the efficiency of it. Where it's not recommended is if you want to do ETL, true ETL, where you read it out of here and write it to there. That's not what drill is all about. It doesn't do that well, if at all. You can write certain things out, but it's very limited. So you're not going to make ETL pipelines or things like that. That's more appropriate use for Spark. Spark is really good at that. Spark can do what drill does. But you kind of have to be a little bit of a programmer to use Spark. There's no hiding the programming from someone using Spark. In drill, it's just all SQL. 100% SQL, nothing else. So super complex data transformations, you have to use SQL because that's all drill does. It's all it knows. So, when you're trying to do some really complicated data transformations, drill is probably not your appropriate tool. I would stick with Spark in those cases rather than drill. So as we do with all these tools that we will learn in the course, we want to talk about the architecture that makes them go, if you will. And so this is how drill is architected. You have one or more clients, and the clients can be a web API or the drill shell, or using a JDBC, ODBC client, as we will demonstrate. We'll mainly show you the web console and the client here. You can also write your own clients using their C++ API if you're a developer and you want to build a custom client. Those clients all talk to each of these, consider each of these to be a computer or a virtual machine or a container in Docker or whatever. Each of these is called a drill bit. One of the drill bits acts as the foreman. Do you pick the foreman? No, it's kind of an election thing. It's like, you're the first person I talk to, you're the foreman. If the foreman goes down, some other drill bit becomes the foreman. And the foreman is responsible for figuring out the query plan and then communicating that query plan with each of the drill bits. So, if you're asking for data from S3 and it's enormous, that data might be partitioned across each of the drill bits, and then the drill bit foreman decides how that's done and under which circumstances the physical plan is carried out on each of the nodes. When you set up a storage provider, that storage provider will save to the drill cluster. So when you say I'm going to talk to S3, all of these drill bits know how to talk to S3. Or when you say I want to talk to Apache Cassandra or Neo4j, all the drill bits know how to do that. Okay. And down here below, this is a really interesting diagram that explains the difference between the query and the logical plan and the physical plan. And the query is what we know. It's just a regular old SQL query, right? We submit that to drill. The foreman parses that query and converts it into a set of logical operators, a logical plan, and then each of the foreman then optimizes that logical plan into a physical plan, and the physical plan is what actually runs on each drill bit. It's carried out by each of the drill bits in the cluster. Again, just like everything else we've done in this class, it'll all work with a drill cluster. We just don't have a drill cluster. We have a single node instance of drill, just like we have a single node instance of Spark. Okay. All right, let's do a little walkthrough of drill, and we'll do like a big picture. How do I use the drill web client? Writing a query in drill. The web client's not the best tool for using drill, but it's kind of like the only tool we got. I will show you another tool you can use in drill that you'll get when you install the ODBC driver. But I'm going to encourage you to just stick with the web client for now. We'll also demonstrate how to look over the previous drills you've done. When you actually run a query, it's called a drill. So, drill's a noun, drill's a verb, right? And then we will also demonstrate how to run that query in ODBC to give you a flavor of how drill integrates really well. Because this, again, if you're going to have it be a BI solution, it's got to integrate with BI tools like Tableau, right? So I will demonstrate that. And we do use the ODBC middleware, Open Database Connectivity middleware, to do that. Okay, I'm out here at my terminal, and one of the first things I want you to notice is when you're running drill in Docker, we expose two ports. We expose 8047. 8047 is, let me zoom this in. I don't want to zoom it in where it becomes incoherent, but right here, 8047 is the web client for drill. 31010 is the port that we use for database connectivity to drill, so ODBC connectivity to drill. So both of those ports are exposed to you. What that means is if I go to a browser and open up 8047, I see this. And this is the drill dashboard, and you'll see that my drill cluster has one drill bit. And it tells you how much memory is being used and things like that, and what version of the drill bit it is, and I can turn it off, turn it back on. And I don't have authentication on. I don't have encryption on. It's a pretty bare bones setup of drill. There's also this little options area where you can set a whole bunch of configuration options in drill. I've tried my best when I set drill up to set these up to be as compatible as possible. But believe it or not, there are some weird things in drill that you may have to flip a bit here or there to make things work. I hope it doesn't happen, but if that is the case, I'll probably document which one of these things you have to go into the bowels of drill and change. Notably, when you change these, they change across all the drill bits in the cluster. Okay. So the first thing that we see is, let's go to, there's query and profiles and storage and metrics and threads and logs. Logs are great when you have an error and you can't figure out what the hell's happening and you got to go Google it. But let's go to storage first. So in storage, you'll see that there's two that are set up by default. One is DFS, one is CP. And CP is like the hello world of drill. It's set up as what is called the class path. And in the class path, there is a configuration that points to a JSON file. I'll zoom this in a bit. Okay, there's a JSON, right? See, these are all the file types that are available. So this class path is of type file, and then these are all of the formats that are supported. So it'll read a Parquet file, it'll read an Avro file, it'll read a JSON file, it'll read a text file with extension TSV, and it'll delimit that with a tab. It'll read a CSV file as text, but it has no delimiter, so it'll use comma by default. And you can see there's all sorts of different file formats. It even supports Excel, like just raw Excel. What's really kind of neat is if you point it at images, it will read the EXIF data, the metadata from the image. So it'll read like the dimensions of the images and tabularize that. So it does, and it'll even read geo shape files. So it's pretty cool, all the different formats you can read. Now, can you make up your own? No, you have to read the docs. These are the ones that are available. That's just the way it is. So what I wanted, why I showed you this is you might be saying, well, what the hell is this CP that he's about to do here? And what I want to say about that is when I go to query and I type in, CP for my schema. I guess I could do this first. I guess I could go show databases, and we'll run that and run this drill, and it reads. And then so you say it's a CP default, DFS root, DFS temp, information schema. These are the databases that are available in drill. Every time you configure a storage plugin, it adds a new schema. Every schema that you add has a default, right? So CP default I don't have to put the word default on there. I could just use CP. So let's suppose I want to see what's in CP, what kind of tables are in here. I can go to here and put in my schema of CP default and then do show tables. Now, think about this. If there's some JSON file out here or some CSV file, it's not going to be able to drill that into a table. It doesn't know how to do that. We didn't set any schema. This is unreasonable. So the show tables really only works when you're talking to a relational database, or you're talking to Hive, or you're talking to Cassandra or something like that. All right, so let's go back and try a real query then. So there is a file in that folder, because I know this, because this is how drill is set up by default, called employee.json. So I can say select star from CP, which is my storage provider. See if you have the sample up here, and then employee.json. Now, you cannot invalid SQL. You can't do employee JSON like that. You can't do that because the dot separates a table from its schema. So this will not read the file correctly. This will give you some kind of error. Says can't find the schema, right? So you need to, in drill, when you want this to be one thing, you need to use the notorious backticks, which is above the tab key, like that, the backticks. And then when you use the backticks, it reads the file, infers the schema, and poof, you get data back. It's like magic. See that? And it doesn't show you all the data at once. It shows you 10 at a time, but you can actually elect to see the whole thing if you want. And then you get the entire set of drill data output. You can also export it down in CSV format or whatever. Now this guy right here, this is the actual query that was built from your SQL. So if you click on this, you will see the query, and you will see the physical plan. Okay, and if you look at this, oh my gosh, this looks really similar to the Spark directed acyclic graph. And if you think about the way these things work, you know, it's pretty much using the same kind of logic as Spark would use. You know, we came up with an approach that works, and we use it in just about every tool that we have. So there's a physical plan. Here's a visualized plan, right? So we scan, we do a project, we screen. I guess I can add a where clause in there to show you, you know, basically what happens. Let's go back to the query itself and run it again to see the output. I know this is a long demo, but it's pretty cool. And let's take this position title store manager. See that store manager? Let's get all the store managers. Where position title is store manager. Okay. Now I could screw this up. It might work, it might not work. I don't know. Right? We'll find out. Okay, that worked. I got lucky. Right? And then let's go here and look at this query profile again, and then take a look at that visualized plan. And you see it's a lot longer now, and it does a scan and a project and then a filter, and then a selection vector remover, which I don't really know what that is, and then it does a couple more projections. Okay, and this is the actual visualization of this plan, which is how drill does what it does. Okay, probably improve this plan by not using dynamic star, but by putting in the columns that I want. That would eliminate the row cost. So there's a lot of complexities here with drill. And I wanted to show you that these numbers show you the orders, right? So this happens first, and then this happens last. And that there is a way to see what drill is doing with the query that you write. And that's pretty beneficial. Now, when you go under here in profiles, you will see a history of all the queries you ran and whether they worked or didn't. And this is useful if you need to go back to any one of these drills and edit that query and run it again. Okay, so it's super handy, super easy, super duper convenient to get to things in drill. Okay, so let's go big picture now. There is a website you can go to that was in the slides that lets you install the the drill database driver. So if I go up here and go to, let's just open up a tab, drill Apache org docs installing the ODBC driver. And you can get the driver for Linux, Mac, Windows. You go here, you can download the driver, takes you out to a website where the driver is available. And then from there, you can get the driver. Right? So in here, I see all these different, drill, and then you open one of these up, and then, there's the installer for drill. So if I've already installed the driver on here. What's nice when you put the driver on here is not only do you get the driver, but you get a tool called the Drill Explorer. See that right here, the Drill Explorer? And this, what am I connecting to? And there we go. And see, you can browse, you can browse your sources this way. Now, if you look through your CP default, it doesn't give me any metadata, it can't, right? But I can write a query in here, right? I can say select star from CP employees JSON. And I can preview that query. Screwed something up. Let me go see what I actually did in drill here. There. Oh, employee JSON, not employees, right? So I go back here and I can put in employee JSON without an S. And boom, it runs my query. So, this is another drill client here. It's, kind of crude. The web client's a little better, honestly. Gives you more information, but it works. Now, here's the real punchline. I want this in Excel. I want this in Tableau, right? So I guess I'll use Excel because I have that on here. Okay, there we go. And get data, other sources, ODBC. From ODBC. Then it will pop up and say, hey, where are you getting your data from? And there's drill, mapper drill. And in here, you have to put in where you're getting it from. Then it runs that drill query on the drill farm. You don't need a username and password because I'm not doing any authentication, but you have to put something in anyway. I don't think it uses any of these because I don't have authentication set up. And then boom, it just drilled your data. So you might be saying big friggin' deal, Mike, but you got to remember this data could come from anything that you can configure drill to chew on. So you configure a graph database, and then you join that graph database to some JSON file you have in an S3 bucket. And then as long as you know the SQL statement to put in that drill ODBC driver, you can query it and pull it into Excel. And then do your pivot table or whatever, or you can pull it into Tableau or whatever. Now, it's not big data anymore, but at that point, that's usually how the cookie crumbles with data analytics, right? There's very few big data analytics tools out there unless you're using something in the cloud. Okay, so that is a nice demo of how drill works, and I think the moral of the story at this point is if you can get drill to read it, you can get any BI tool to read it. And this ends up being amazing because drill will let you run SQL over anything. All right, let's talk drill storage plugins. This is where the magic happens in configuring drill so that you can do just about anything you want. So drill talks to relational, no SQL, file-based structures using what's called a plugin architecture. Plugins are in JSON format, and you have to configure the JSON file. This is kind of the unfortunate thing. If you don't get that JSON file just right, drill's not going to be happy. Once you get it working, it's going to work. And then in your from clause, you identify the storage plugin you want to use as a database. And then any options on there end up being usually the table or the schema. So like from CP employee JSON, for example. And then we use backticks on database object names. And here's a bunch of supported plugins. You can query relational, you can query Hive, HBase, and HDFS. In this class, we'll query HDFS. We'll just skip the Hive stuff. You can query a variety of NoSQL like Mongo, Cassandra, Elasticsearch, Kafka. We'll query all of those. You can query S3 and MinIO. We'll do that. You can query the local file system. You can query over HTTP, which we will do as well, and more. So what does a drill storage plugin look like? Well, it basically is a JSON document, and there's always a type, and there's always whether or not it's enabled, and there's always a connection, and then there's one or more workspaces, and then there's one or more formats. And when you're connecting to a database like Cassandra or MongoDB, this is really easy. It's only where you have all these different options when you're querying a file-based provider like S3 or like maybe HDFS. Those are where it really gets kind of wonky. So what file formats are supported? It supports the common log formats. It supports TSVs, CSVs, all the delimited kinds of formats that you know and we used in class, custom delimited formats. It supports JSON files, XML files, Excel files. It slices and dices. It does ESRA shape files. It does big data file formats like Parquet, HDF5, and Avro. It does quite a few different formats. And this is what makes it so great, is out of the box, it does so many things. And it's easy to run in a container. So we scope each table by storage plugin provider. So we have workspaces root, and then we can say like, root is like this folder, and then stuff is this folder. And then based on picking root or stuff, we can determine which one is writable and which one is read-only and all sorts of other things like that. And then when you have root, you say select star from provider.root.file in this folder, or you might say select star from provider.stuff.file in that folder. If you leave off root or stuff, it assumes default. All right, let's configure MinIO to be drilled. As I like to say, we will use this in this demo. We will drill MinIO, and we'll keep it pretty simple. What we plan to do here is I will connect MinIO to a bucket, and then I will put an Excel file in the bucket, and then I will query Excel like it's an SQL table, and I'll have a lot of fun doing it. All right, let's get to it. Okay, I'm back out at the console here, and I have this file, exam scores. It's an Excel sheet, and this is what it looks like. And it's a true Excel worksheet, and I want to take this and I want to upload it to MinIO, and then I want to drill it. So what I'm going to do is go to MinIO, and I'm going to log in because I'm done using the console. And let's make a bucket here, and let's call this bucket, let's call it eDemo. So let's make a bucket, eDemo. Let's create that bucket. And I could make a folder in the bucket, but I'm just going to upload the file. And I got to go find that file now. So this is my little secret. I like to copy this here and then paste it down here like that. Yeah, there we go. And then put exam scores in there. Zoop. Okay, now I have to configure drill to get to this bucket. So I'm going to go back to drill, and I'm going to go to storage. And there's two ways you can do this. You see there's a bunch of plugins over here that query a variety of databases. These are the ones that work out of the box, provided you configure them. I could take the S3 one and update it, and then edit it and save it. And then in that case, it would be select star from S3 dot. Okay. Another way to do this is I can create a blank one like this. I can do create, and then I can give it a name like MinIO. And then I have to put the MinIO config, which is going to be very similar to the S3 config. So you're going to be configuring a lot of drill stuff. So what I've done for you is, if you go out to your terminal here, where you have advanced databases, if you type in code dot, it will open up the Visual Studio Code editor like this. And that editor has in here, let me close, I kind of like exposed it because I have them all open already, and close these. The editor has a folder called Drill Storage Plugins. See that right there? Drill Storage Plugins. And then in there are a bunch of examples on how to configure, Cassandra. And here's how you configure Cassandra. Not much going on here. Here's how you configure S3. So if I go to min.io drill, there you go. So I am going to start with this. So I'm going to just highlight it all and copy it. Control A, Control C to copy it. Then I'm going to go over to my drill site like that, and I am going to paste in the config and then hit create. And that is going to give me this. It's enabled and it's ready to go. Now, it's probably not configured correctly. So it's not called eDrill. I called the bucket, what did I call the bucket? eDemo? eDemo is what I call it, eDemo. So I need to go back, got to find the right drill. eDemo is the bucket name. And then all this stuff looks very familiar. It's kind of the same config that we had in Spark. And I have a default location that is the folder that's right off that bucket. And that's it. Now here's the supported formats that I've configured. PSV, CSV, TSV. Here's Excel. And any file that ends in XLSX, or maybe I'll also add just plain old XLS. Those are going to be treated as Excel files. So the dirty secret of the way that this works is because the file ends with this, it applies this type to it and tries to read it as an Excel file. So if you have a CSV file and you end it with XLS, it's going to read it with the wrong format. So that's something you just got to know. So I'm going to update this. And then I'm going to go back to the query and I'm going to type in show databases to show you that I've lit it up. There it is, min.io default. Remember, I don't have to use default. Okay. And so let's write a drill now. So let's say select everything from min.io dot, and then I use my backticks, and I think it was exam-scores XLSX. And we hope and pray it works. That's kind of the way it works with drill. And it did. See that? I just drilled an Excel file. So again, now that this is a table, I can join this table to any other table, whatever, if I have some common business key that they share. Okay, so that's drilling things in S3. It doesn't really matter what it is. And just to show you that it really does support plain old SQL. If I look at this, right, maybe what I want to do is I want to get the average student score by exam version, right? So, this is just SQL. Select exam version student score. The thing that's going to drive you nuts, by the way, is remembering the column names, right? Exam, see how it's case sensitive, exam version, student score. Knowing that kind of stuff, I'll show you. I guess maybe having errors is probably good. Exam score, student version. Okay. See that? No. What the hell happened? Again, it doesn't have a schema. It has no idea what the schema is. So I can put in any damn column I want, and it'll try and drill it. How about the column Mike is a god? I wish, right? It doesn't matter. It tries to drill that column, and I get back a row for each row in the Excel sheet. So unless the database that I'm drilling is a real database and has a schema, this is the game you're going to play. It's mind-boggling. So you got to make sure you do these right. It's a headache, man. You got to know. And there's no way to describe this, right? You can't run a describe statement to see the schema. See, it's still not working, right? So maybe I need to use my friend backticks. And try backticks here. Okay, I obviously don't have the right names here, so I need to go back and look again at select star. This is the world of drill right here. Exam version. There it is. I thought it was a student score. Student score. Class section. Here, let's just try exam version. Exam version, right? Exam version. There we go. See, now I get it. Now it's working. And then what was it? Student score? Student score. There we go. Okay. And then now I can do what I really wanted to do to begin with, is exam version and then the average student score, right? And then I want to group by exam version. And God, I'm not typing that. Well, I'll probably screw that up if I try to type that in, right? And then it takes a little longer, but there you go. So I ran an aggregate group by clause over an Excel spreadsheet using SQL. It's pretty cool. Again, the trick is if you don't have these column names just right, you're gonna experience some pain. You're gonna have a little bit of pain there. All right, let's do the same thing with HDFS. Let's talk about drilling HDFS. So you're going to see that it's not really much different than drilling S3. It really isn't. So let's rinse, lather, and repeat, and do that. So in order to set this one up, because I'm kind of lazy, there is a setup in Spark that I will do. I'll show you. Okay, I'm out here in Spark before I get into drill because I want to run, I'm in here in work, content, drill Spark, and I want to run the Spark config and then this setup area down here to make sure that I have everything all configured. Because otherwise, I mean, how am I going to get files up into MinIO and up into HDFS to do examples, right? You don't want to sit there and watch me fumble around with that. So this is something, if you want to follow along, you should do it. Run this and then run this. You won't see any output, but when you're done, if you go to HDFS and go browse the file system, you will now see that in user root, you have a eDrill. See that? eDrill. And in there, you've got a bunch of stuff. So you got things to work with now. So here we go. Let's do the HDFS demo then. So I'm in drill and I got my storage plugins and I could go over here and configure one of these, but the better thing to do is just create one. And then in here, I'm going to put in, I already put it in HDFS, and then here I'm going to put my config and I'm going to go back to VS Code and find the HDFS one. And because, you know, this is me, your Uncle Mike has configured this for you, so you don't have to. You've got to tweak it a bit, but it's a good start. So I'm going to copy this and then go back here. This is the hard part about drill, is manually doing these. Whenever you want to add a new connector, it's like, oh boy, here we go again. And this has a lot of options in here: XML, Parquet, Avro, CSV, and then it's already pointing at our name node. So it's ready to rock and roll. I am going to save it. Make sure, see, it says it's right now it's enabled, right? Don't disable it. I don't want to disable it. So it's all set. So I go back to query again, and here we go. Around and around we go. So, show databases. Yeah, I got to spell it right. Databases. And in enough time, we will see, you know, HDFS root, HDFS default, HDFS temp. Okay, so don't get excited. There's 3 HDFSs. Go back to storage. Look at it. Workspaces. I have the temp is here, and the root location is the right one, user root. So I want to use root in this case. That's how I have it set up. I could change this to default if I want, default. You can do that. Okay, but I just wanted to show you different ways that you can configure this thing. Understanding how it works is really important. So we're going to just ignore this. I'm just going to back. And then let's go to query and let's give it a shot now. Select everything from HDFS. Okay, here we go. Now, HDFS points to user root. User root. Then I got to go to eDrill. So here we go. eDrill grade CS. Let's do, I don't know, let's do customer CSV. So eDrill customers CSV. Backticks. Finding. Oh, it didn't get it. eDrill customers CSV not found within HDFS. Now, I think it already points at eDrill. No, maybe not. I don't know. Let's try it without. Let's try it like this. Not found. Okay, so maybe it's like this. /eDrill. No, it's not like that either. Okay, so now I need to think about this for a sec. Yeah, I fell victim to my own lack of success. When I don't put .root here, I just explained this and I screwed it up. When I don't put root here, it assumes default. If I go and look at storage again, root is user root. Default isn't specified, which means it points at just /. So to correctly drill this from default, it would be user root. Like that. And then it works. Okay, now it doesn't show the format correctly. We'll get to that in 1 second. Let's just take a baby step here. It at least shows me data, right? Now, if I don't want to have to put user root in front of here all the time, I configured the storage plugin so that user root is called root. I could have called this X if I want. Doesn't matter. So now I can go and drill and say hdfs.root. And then I don't need to put all this in there. I can just do that. And I get the same thing back. Boom. Okay. That's what I meant to show you. But I think that's good. I got to really do more errors. Errors are good because they help you understand the hows and whys of how it works. Now, here's the next thing. It did not figure out that this first column has a header in it. So what I got back is a column called columns. See that? I got one column, and it's called columns, and it is an array. Okay, so this isn't what I wanted. So what do I need to do? I need to go back to that storage plugin, and I need to find the file format CSV. See, I see CSVH, and the extension says CSVH, and it says extract a header true. So if my file doesn't end in CSVH, it's not going to extract the header. See, CSV does not have extract header true. So I need to add this. I need to take this and add it to the CSV format. You got to make a choice. Are you going to extract the header or not when the file ends in CSV? In this case, I would like to extract the header, so I'm going to add that in there. Now, it does check syntax. See, if your JSON is screwed up, you do get a red X. It tells you to fix your JSON. Okay, so now I corrected that. Now let's go back and re-drill. Let's see what happens here. And there we go. Now I get a table. Yay! Because it knows that first row has the data in it. And again, all the SQL rules apply here. I can do group by having. I can do a window function. I could use a common table expression. All that stuff is good. All right, now we finally hit something that, let's just say it, Spark can't do. All right, you got to write a heap and help in a code to make Spark do this. And what do I mean by this? Querying an HTTP API, a web API, a REST API with drill. Not only can you query an API, but you can also query files over HTTP, and we will do both. This might be a long demo, but I do want to get to and show you the Open Weather Map API, if I can do that. So we'll do a couple of examples here. We'll do an example that just shows you reading a straight file, reading a folder, and then using the required tail example to give you what's after the folder to get to the files within the folder. Then we will look at how you can parameterize your query and use the where clause to help you with that, which is really kind of cool and sexy. And then we will try to tie it all together, and I will try to query a weather API in drill, and you'll just go, what? Or maybe you won't. I don't know. Maybe it'll be frustrated and it won't work. Well, let's try it and see what happens. Alrighty, here I am once again back out in Apache Drill. I'm in the storage section. And rather than create this time, I'm going to update the disabled storage plugin because I want to show you this is all you get when you start with a HTTP config. It doesn't say type file. It says type HTTP, and then it says proxy type direct. That means you're not using an HTTP proxy at all. So that's it. There's nothing more in here. Then what comes after this is one or more different setups and configurations that you can do. Okay, so now that you've seen that, let me create one. Let's call this HTTP. In here, I am going to go to this, and this has got a lot of stuff in here. And rather than me adding it piece by piece, what I'm going to do is put it all in there and then explain each of the pieces. So you'll see that I have HTTP, and that says connections. And then in connections, I can name them. And this one's called Sunrise. And what's important about this is not necessarily the name. The name is how you're going to access it as a table. And then this URL ends up being where you go to get the data on the web. And then all these other things are configurable. So I'm going to start out with the simplest version, which looks like this. It's going to say type HTTP. I'm going to kind of build this, and then I'll just paste in all of it. But I want to build it first because I want to show you sort of what drill does here. So I'm going to say type HTTP, and then I'm going to go back to here, and I'm going to say, where's that one here? Stocks, right? I want to grab this stocks one. Just going to grab this. And what I need is connections, right? So I'm going to go down here and say connections. Oops. Oh. Connections. And then I'm going to give it some connections here. And then here's going to be my first connection. Stocks. And then this URL points to where the JSON data is on the web. And I'm going to show you that by copying and pasting it up here. See, there's where my JSON data is on the web. So it's like, boy, this is on the web. I sure would like to query it. Right? All right, so let's go back to my drill config, and then let's finish this off. And then I'm going to put in a closing bracket for stocks, and then another closing brackets for connections, and then a final closing bracket for type. And then I'm going to hit create. And then what I'm going to do is, it's over here, HTTP, and then what I'm going to do is enable it. And then I'm going to update it and show you that it adds a whole bunch of options in here. These are all the default options that it will set on there. Okay? So now that you understand that, let's go back and just copy and paste what I had in VS Code. Let's just copy all this and paste it like this. Okay. And I will show you each of the examples. Okay. So I'll be coming back here a lot. So I'm going to update this, and then what I'm going to do is I'm going to show I'm going to show it right here like this. Okay, that's perfect. And then I'm going to query things from here. So I can do a show databases. And I run that, and now I get HTTP JSON samples HTTP. All right, and why don't I get any of the other ones? Well, they might be there. Maybe I'll go to next. They're not. Okay, let's try to write a query. So if I go back to the config, you'll see that this is the wrong one. I need to go to HTTP. You'll see that there's one called stocks, and it points directly at this file. So I want to do that one first. Star from HTTP stocks. And there you go. It read that JSON file and tabularized it. Pretty wild, right? This is the JSON file, and it tabularized that. That's pretty neat. Very powerful. So there's another one here that I want to show you next called, here's another URL. And this folder here, I guess I can't show it to you like this. I'm going to show it to you like this. And then there's this data sets, and then JSON samples. And see, there's a bunch of these files in here. There's a bunch of JSON files in here. And I want to write my drill so I don't have to make one for this, make one for this, make one for this, make one for this. So what I can do is I can configure that drill storage plugin to point at the root folder, and then I say require tail true, and that means you have to add the name of the file after the JSON samples. So let's go and do this a la carte. Let's go back here, and I want to query this, well, I'll just query this FudgeMart products JSON one right here, okay? So watch this. I go back to drill, and I do select star from JSON samples dot. That did not paste right. I better copy it. I don't have any confidence that I will type it correctly. And there you go. It just read this file. Let me show you what file it read. It read this file. See that? It read that in. Pretty wild. Let's do another one. Here's one, U.S. senators, right? Let's see this JSON file. Okay, this one's going to be interesting. Let's see how it reads in. So I go here, back. Now I just change this because this points at that folder. I'm just going to grab U.S. senators. That's what the allow tail does, is it allows you to finish off the URL here. I get back this data. It's pretty cool. Now we'll deal later on. We'll learn how to address, nested data and stuff like that in drill. It's actually pretty easy. But for now, let's just be happy that something shows back and we don't get an error. Like if I put in that, I get an error. Read error, request failed. That means it's not there. File's not there. Okay. So that is the feature that require tail feature here. Require tail. And that permits me to add file names or path names at the end of this URL. And I can say select star from HTTP JSON samples and then finish off the URL to get to the actual file. Senators JSON in this case. Let's do another example. So let's kick it up another notch. Here's the next example I want to use. Here's a simple API called Sunset. And this API gives you back this data here that tells you when the sun is going to rise and when the sun is going to set. Okay, pretty simple stuff. Okay, and it's JSON data. How do I get this data? Okay, well, here's the URL, right? Now, one of the things that you can pass into this is a lat and a long and a date, and it'll tell you when the sunrise and sunset would be on the globe at that date. Okay, so those are arguments that I need to pass in to make it work. So if I go back here, you'll see that it takes lat, long, and date as parameters, right? And that usually means in a web browser that you're doing this. You're saying, lat is 43. Long is, oh, I don't know, minus 74. And see how it changed? It changed based on that lat and long. If you don't believe me, let me try another one. Lat is, let's go closer to the equator, 3. And then just watch the data. Okay. Sunrise and sunset change. Okay. I didn't put a date in. I won't bother with that part of it. Okay. So you see that you can call the API differently with different pieces of data. So how do you make this work with drill? Well, it's really easy. When in the drill config, you specify each of the arguments up here as parameter. And then what you do is you write a query that looks something like this. Let's go back here. This is called sunrise here. So that just queries. I don't know what Latin long it's using. 0, 0? I don't know because I didn't give it any Latin long. So I can go back here and do where lat is 43 and long is what, minus 74 is what I said. And see, it queries those times. So if I look at this, let's just make sure it's right. Day length, 10 hours and 37 minutes. I go back here, 43.74. Just make sure we're looking at the same thing. And it says 10 hours and 36 minutes. So it's the same. Now, here's another nifty thing. You see that it has results, and then the data I want is in results. So in the config, what I do is I say data path results. And what that does is it chews on the JSON data starting at the results key in JSON. Okay, and this is best explained with the last example. So there is an API called Open Weather Map here. And I'll just go there. And Open Weather Map looks like this. Just do. And I have, it's called the One Call API right here. And you need to, here's how you call it. You put on the LON, the lat, and the API key is what the app ID API key. And it will return back a JSON structure like this. And then, you know, depending on whether you want the hourly forecast or the daily forecast, these are keys. So what I did in my drill config was I said, you know, lat, long, app ID, units, these are all parameters I can give it. And then this will get me the daily key. This one gets me the hourly key. So I have one way to query weather hourly and another way to query weather daily. So let's get today's Syracuse weather as a final example here. The hourly weather. So I would say select star from HTTP weather hourly. And I need to give it a Latin long, and those are approximately Syracuse. And then I need to give it an app ID, and I need to put in my API key. That's my API key. And I run it. And I get a data read error. Bad request. So usually that means you put in a parameter wrong. So I have lat, and you see it didn't put long in there, right? And that's because I didn't do the right one. It's not LNG like this. This API, it's called LON, right? And I can check that in the way I configured it in drill. LON, see that? All right, and then I can run this now, and this query, it went out and queried the web, and it brought it back and put it in a table for me. It's pretty wild. Now, these temperatures don't make a lot of sense to me because they're in Kelvin, so I got to go back and fix that. And I can do that with, where was that? Units. See that? Units. And units equals imperial. Do that, and then I see today it's 24 degrees in sunny Cuse. So there you go. Drilling over HTTP. Pretty amazing stuff. Very useful. Great way to query APIs and get that data in tabular format. All right, let's talk about drill SQL a bit. Again, ANSI standard SQL. There's some features in here that you'll like. View support, window functions, common table expressions. You can create tables from queries using create table as. Here's the supported data types for drill. I guess I should pop that open and show you that. They're basically like, ints and strings and dates and things like that. You don't have to specify a lot of specifics in there, so that's good. Let's talk about how you deal with the fact that there's no schema in these text files. When there's no header, drill returns a single column, which is an array of values. You can use the column structure to extract out the columns you want, and then use cast to change the type. So it's really kind of on you to deal with adding schema to data that you read from text. And, this is just the nature of the beast, really. And let's just do a really rapid demo of that. I'm out here in HDFS, and I'm in the root drill folder, and I'm looking at this grade CSV. This grade CSV does not have a header. So this is a really good example to use in this case because there's no header here. And what I want to do is I'm going to go back to the drill config, and I'm going to make sure that my HDFS config for the CSV format. See, CSVH has a header, but I want to make sure regular CSV no longer has a header. So I took that out. See that? No more header in there. Okay, and I have to do that or else the example won't work. And let's go try the query now. So it's select from... actually, I want to leave this one on storage, and I'll keep using this one for queries. This one will stay on. I got these backwards. Let me flip it. Okay. And let's do a select from HDFS. E-drill was grades CSV. And I got a mistake in here. Oh, I did it again. HDFS root, right? Root. There we go. And you'll see that I just have one column called columns, and then in here I have a list of actual values. So here's how you go about applying a schema when this happens. And this is always going to happen when there's no headers, right? Because drill can't guess what your schema is. It has no clue. So what you want to do is start peeling out the columns. You do this. You say columns. Zero. That's the first one. And just for grins, I'm going to peel out a few of these. That's good. Maybe one more. I don't know how many there are. I should have paid attention, but I didn't. Okay. Oh, it's column, not columns. It's column. Column. Of course, it would help to spell it right, wouldn't it? Was columns. Yeah, it is. So, yeah, typing gets the best of Mike every time. Okay, so there you go. So I split it up into columns. So column 0 is this one. Column 1 is this one. Column 2, column 3, column 4. And now I can apply labels to the columns. And I can even convert the types if I want to. And this is pretty standard SQL. This isn't anything you don't already know or needs to be taught to you. So this first one is as date, right? And if I want to use the word date, which is kind of like not a good idea because date is a keyword in SQL, you can backtick it like that. I wouldn't do that. I would probably just do like G date for grade date or something. And then this one is as E semester. And this one, it was, oh, I forgot. Let's go take a look at what we got. So G date, G semester, course, credits, grade. As G course, as G credits, as G grade. Or how about G letter? There we go. And so now I've got these. The problem is all these are still string types. So I want to make credits an integer type and GDate an integer type. So I would use cast, just like I would use, you'd say cast that as int, just like you would in SQL, right? It's no different. It is SQL. That's the thing to not forget. It is SQL. It's 100% SQL. Okay. Where this ends up being a gotcha, if you don't do this and you go to sum up the credits, it won't work. And I guess maybe I should show you that, right? I know I'm kind of probably going over on time, but the demos are useful, I think. So I'm going to use a common table expression because this query is getting really ugly. Okay. So let's get this warmed up. Okay. And I'm going to say with temp as, I'm going to call that temp because I'm sorry, I really just do not have any creativity left in my body at this point. So now this is a named table, and I can say select, I don't know, let's do G semester, and then the sum of G credits from temp, group by G semester. Right? Common tables expressions are nice. And you see it adds it up. It adds it up quite nicely. Now, if I were to go back and not cast this as int, it's probably going to assume it's text. And I can't apply a sum to varchar types. Ha! And there you have it, right? So that just kind of shows you when you're reading data in and it has no schema, which is most of the time, you might have to go through and do this. And even if it had a title column in it, there's no guarantees it's going to come in as integer. I'm doing the wrong one, aren't I? Let me just undo it. Can I undo it? There we go. Yeah, there's no guarantees it's going to come in as an int. You have to check that. And there is no easy way to inspect the schema because it's not a real table. So this is kind of the drawback / limitation of drill. If I want to put a name on this column, I can do that too. I guess that's where I'll finish it. Let's put a column here as total credits. There we go. Ooh, how cool. See? Neat. Okay, another thing I want to show you here is you can create tables and views in Drill, provided the storage plugin is writable. And there aren't many of these storage plugins that are writable. The file providers are writable, so you can write back to HDFS, or you can write back if you want to min.io. Generally, what I do is I like to write when I'm playing around with Drill. I'll just write to the local file system, and that's fine. So you can do create view. You can do create table, and you say create table blah as select, create view blah as select, and schema is the storage provider, and table name is the table to create. And again, your mileage will vary based on storage provider. Just about all of them that are writable can do a view though. The good news is every drill setup has a DFS temp, which is always writable, and you can always write tables to that. And those tables are spread across your drill farm. So that gives you a pretty good opportunity to take advantage of being able to persist data that you need to and make sure that it's distributed. Okay, let's play around with this in another example here, and we'll create a grades parquet file. We'll create a view from the grades parquet file on HDFS in a different schema, and we'll look at it in MinIO. Normally, you'd be making a view out of like some crazy table joins, right? You wouldn't just be making a view for the heck of it. But I don't need to show you joins and things like that. They work exactly the way you would expect them to work in Drill. They're no different than joins in any other relational database. Okay, let's get into the demo. Okay, I'm back out here in Drill. Let's do this first. Let's do show databases. See what we got again. And I think I want to play around with MinIO. And where's MinIO? I didn't disable it, did I? Oh, there it is, MinIO default. Okay. And let's do this. Let's do describe schema MinIO. And you can see how it's configured. This is actually very useful, right? So if you want to see this from here, you can use describe schema. And it tells you how everything is all set up in here. So let's add what I want to show you here is the default config. Where is it? Is writable true. See that? If the writable was false, I wouldn't be able to put anything in S3. So let's do an example and write a view to S3. And let's go see what that looks like when you write a view. Okay. So back here, and let's come up with a query. So here's just a simple. We could use the query from the last step. That's probably not a bad idea. I could just use that. So here's this awesome query I wrote. Right? I want to take that and I want to make a view out of this. It's a silly view, right? There's nothing in it. I guess maybe I can kick it up a notch by adding in this should be G year. Maybe if I group by G year and semester, it looks a little better. G year. And then group by G year, like that. That looks a little better because I've got a little more data. So I want to make a view out of this. It really doesn't matter. So let's make a view. So create view. And where do I want to make that view? MinIO. And what do I want to call that view? I don't know. Let's call it vgrades. And then as, and then that. And then boom, I made it. What the heck just happened? Let's go to MinIO and find that. And you'll see in the bucket, there is, if I can find it, there should be a grades in here, vgrades. I think I put it in the wrong bucket. Let's check the eDemo bucket. Okay, there it is. vgrades.drill. And you can see it's real small. All it really is the query definition stored in there so that you can refer to it now as a table. So I've got this query and it made my vgrades. So I can do another query here and say select star from MinIO vgrades. That will use my view. So there you have it. So it's a great way to simplify your queries. Simplify your queries by putting them under a name, right? So I put this under a name, boom, easy. Okay, that's views. What about making a table? Well, you can't make tables. Let's try to do this. I'll call it T grades. Can't make tables everywhere. And a lot of times this is just the way the storage plugin works. So what I do know always works is putting them in temp. So if I do DFS temp, I can always put a table there, and I just did. Okay, and so now that data is not a query of the original source, but a copy of that table output. I imagine if you had a pretty nice drill farm, you would definitely have a strategy by which your drillers could save their data somewhere, and you wouldn't have to do this. But this is no longer a view. This is a copy of the query output as a table. So there you go, tables and views in drill. Pretty slick. You can make a table and view out of anything that you can get into a drill table. All right, let's talk about querying nested JSON with drill. This is really kind of the last thing we'll do in drill. So you got to alias the table. This is the first thing that you'll notice about drill is it can be very picky about columns when you're doing joins and when you are getting into nested data. So first things first, I always make a habit, if I'm doing anything advanced in drill, of aliasing my table. Use dot notation for JSON values. There's a function called flatten, which does the same thing that the Spark explode function does, which will transform the JSON array into rows, pivot the arrays into rows. And this will get you access to the array row by row. Okay, so let's do a really nice example in a bit. But if you look at what we have here, and you want to take this value here, Andy, and then have a row for each of these grades. When you do the flatten, it will produce this, right, which has Andy 55, and then Andy 90, and then Andy 100. It produces a row for each grade. Only going to work if you alias the table, though. Okay, let's do an example of fiddling around with nested JSON in drill, and we will use the Google Places API output file as an example to give you something to kind of chew on. And this is in the JSON samples with HTTP. All right, I'm back out here in drill again, and I have pre-typed some of this code in here. I have select from HTTP JSON samples US Senators JSON. I press enter. I get back some tables with nested data in it. So you see there's address in here, and if I go, there's a contact form, and there's a lot, person, and then I have a birthday, person name, first name, last name, right? So maybe I want to get out like their first name and last name as an example. So you might think you could just go, hey, let's do person, first name, person, last name. That will not work. Person is never found because it thinks it's a table. You have to alias this from like this, S for senators, I guess, and then you can say s.person, and then it doesn't think it's a table anymore. It realizes it's a column, right? And now I can get their first name and their last name out of there. You might think, will it work with backticks? Maybe. I don't know. I've never really tried it. Let's try it like that. See, it just throws back nulls. It's like, can't find that. Sorry, can't help you. So that doesn't solve the problem the same way you think it would. Yeah, it just doesn't. So even doing it this way probably doesn't solve the problem. You try it. Take that out. So that's the big thing, is it thinks it's a table, and therefore you must alias these so that it doesn't assume that this is a table. And the reason it does is because of this dot operator. Okay, so that's one thing to keep in mind. Let's do the star again so I can show you another bit. So maybe what you want to do is you want to take these Congress numbers and you want to flatten those babies out, right? So like for each person, you list out their Congress numbers. So to do that, you need to use flatten. And you would just say flatten Congress number, s.Congress numbers. I think I think it was like that, right? I better back tick it just to be safe. And I'm gonna call this CNO. I'm gonna alias it as CNO. And then there's your Congress numbers. There's 3 for each Congress person. Go back here and maybe alias these while I'm at it. It's fun to drill, but frustrating. Where it gets frustrating is when you create an incredibly complicated query and then you have some strange error that you can't seem to find the forest through the trees for. And that can be some mind-boggling at times. So that's basically how you deal with nested data in drill. All right, I said I'd mention it, but we're not going to do a demo of this. Table joins kind of work the way you would expect. You're going to have one table that comes from some storage provider and then another table that comes from the same one or a different one. It really doesn't matter. And the real key here is you want to make sure you alias any table that you use in the from clause. You want to just kind of get in the habit of doing that. And this is a great example of taking some customers from S3 and then some survey data that's sitting out there on HDFS and joining them together to get some actionable data out of there. All right, that concludes drill SQL, and we won't spend a lot of time here in Spark SQL because I think you almost know everything you need to know already about Spark SQL. The dirty secret is the things that you learned already that pertain to the way Spark worked with Hive still apply. It's just when you don't have Hive config, it uses Spark's version of SQL instead of Hive's. But anyway, the data frame API, you can take any data frame you want and register that as an SQL view with Spark. And then at that point, it will treat that as a table that you can use in the from clause. It's really a view, but it treats it as a view that you can use in the from clause. And Spark is ANSI compliant with SQL, and if that link will tell you all the details about what is involved with that. So if you want to know if a certain feature that you want to use in SQL is available, that's a great place to go. And a reference of the Spark SQL syntax is available at this link. And that's another really great place to go if you just want to see what kind of commands are available. Again, not possible to teach you all of them, so I teach you where they are. So how does this work? You have a data frame, and then you call a function on that data frame called create or replace temp view. And what that will do is that will register a data frame with the current Spark session. And then, in turn, you can use spark.sql to query it. This is different from Hive because the Hive, those tables persist independent of the Spark session. Okay? These tables only live around during the current Spark session. When you shut down the Spark session and start it back up again, you're going to have to create that temp view again. Okay? Every time you query it with Spark SQL, the output is a data frame. So once you get a data frame out of that, you can register that data frame as a temp view, or you can query it with plain old Spark and use the transformations that we learned in the previous week. So I can say data frame, create or replace temp view, some table, then Spark SQL select star from some table, and then show. So let's do a demo of this and sort of conclude out the kind of cool things that you can do with Spark SQL. What I'll do is I'll load in some data frames and then make some views and then write a couple of queries and then show you that if you know some SQL, you can do some really interesting things in SQL. And even user-defined functions work. So there's a lot of nice things that seem to just play nicely in Spark SQL. All right, I'm out here in Spark. And let me zoom this in a bit. And remember, this is the example that you ran from before, the setup, right? And remember, it doesn't matter where our Spark data frames come from. They can come from S3, they can come from HDFS, they can come from the local file system. It's irrelevant. Once they hit the data frames format, we can treat them like they came from my nose. It doesn't matter, right? So I have in here this data frame C for customers and this data frame S for surveys. And then way down at the bottom, I'm going to show you some stuff that we're going to do in Spark. So I'm going to take that C and I'm going to register it as a temp view called customers. And then I'm going to take that C and register it as surveys. And I'm going to print both schemas to show you what's a what. And I'm going to actually take these. I'm going to take this and cut it out like that. So let's run that. And you see that, this gives me a chance to see what columns are in there. And then what I'm going to do is I'm going to write an SQL query. And I'm going to say, select C email, right? And then gender and state, blah, 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 blah. And then from here, I'm going to grab some things like month's customer and own home from the other data frame. And I'm going to use backticks because there's a space in there. So, the drill syntax and the Spark syntax, very similar. I'm going to say from customers left join surveys on that, right? Where they're in New York and they've been a customer for more than 5 months and they do not own a home. Just to show you that you can express this in plain old SQL because I registered these as views. And then I will run Spark SQL to query it and then get back a data frame and then show you that data frame. And there's the output and there's the schema. So again, the output from Spark SQL is a data frame. So this opens up a lot of fantastic utility to you, because if you can't figure out how to do it in Spark code, you can write it in Spark SQL. If you can't figure out how to do it in Spark SQL, you can write it in Spark code. You've got a lot of options at your disposal here, and they can be used in any way that you see fit. The other thing that I'll show you here is when you do something really complicated, like here's a really long one where I'm getting the email, gender, state, months, customer, own home, and then I'm parsing through the household income. And when they select prefer not answer, I'm going to make that null. Otherwise, I'm going to cast the household income as a double, because what I want to do is deal with the fact that they didn't put a number in there, but I want to be able to add or average these household incomes up. So what I'm doing here is I'm using the case statement that is pretty friendly in SQL to say when it's null, or when it's prefer not to answer, set it to null. In any other case, it's going to be a number, so I can safely cast that without throwing an error. And then this gives me this output and creates another data frame, right? And what's fascinating about making these data frames is you can explain them and see their plan. And again, this plan is optimized to the Spark transformations. And it doesn't matter if I did the transformations in SQL or I did them in Spark code. More than likely, this is going to be the same plan. This is going to be the same path, the same graph that it uses to manipulate the data. And then the other nice thing that you can do that's really, really handy is when I come up with something insightful, I can register that as a temp view. And then use this to foster further queries. Now, if I want to save this data more permanently, I should probably write it back to S3 or write it to HDFS or something like that. But this is great when you're working in the pipeline and you need to pivot between a Spark transformation and a full-blown SQL style transformation. That create or replace temp view is just golden. The other neat thing about doing this is it works with nested JSON, right? So here I am using the Google Places one, and if I show you what this looks like really quickly, if I do GP print schema, you'll see that, boy, that Google Places is pretty nested. That data is pretty nested. See that? So I can, I can get the name out, which is right at the top level. I don't have to worry so much about that. And then I can get out the geometry, location, lat, and long, which are right here. There's that name, by the way. And then geometry, location, lat, and long. I can peel those babies out. And then I can explode the types, which is right here, which is an array of strings. And I can write that in SQL if I don't want to write it in Spark. And then I can get a table out like this. So you have so many options with Spark, and it's what makes it so nice. And the key is to register that data frame as a view. That's the key. It even works with UDFs, by the way. So I wrote a really simple UDF that just converts some arbitrary string to uppercase, right? And then what I'm doing is I'm calling a query, and that query is calling the uppercase function. And you see the output actually uppercases the email. And just to show you that it does, I'll put email in here twice so that you can see you have the regular email and the uppercase email. One thing to note, when you do this, you do have to call Spark UDF register. And you normally don't have to do this in Spark when you're just going to use the UDF in regular Spark. But if you want to use the UDF in Spark SQL, you do have to register it. And the syntax is, what is it called in Spark SQL? What is the name of the function? So, I could have called this UC instead of uppercase. And then I could have called it here UC, and then it still works, right? Because UC is its name in SQL, but this is the name in code. Generally, it's a good idea to probably have these match, right? You don't want to confuse yourself. You don't want to be in the business of making your life more difficult. So you definitely don't want, this to be one name and this to be a different name. That's usually not a good idea. Okay. One of the last things I'll show you is if you want to see all the views that you have, you can always just say spark.sql show views, and it will show you all the views that you have in place. This is temporary thing is when you're using Spark views, they're temporary. If you're registered with Hive, you can have permanent views. But the temporary views are fine for most Spark type transformations. It's just when you need to pivot from, I've got this traditional transformation that I'm doing in Spark code, and boy, it would be so much easier to just do it in SQL. So I'm going to register my data frames as tables, as temp views. Keep calling them tables, but they're really views. Register them as temp views, and then I'm going to run that really complicated SQL, that I had, whatever it is, to solve that transformation. So that's Spark SQL in a big fat nutshell. Again, the way it works is you take any data frame and you create it as a temp view. And then once you do that, you can use SQL on it. And you use spark.sql. Boom. Simple. Easy. Let's sum up this unit. We learned a lot about running SQL over whatever the heck we want. And really the foundations in that are the transformation over time from heavy ETL, we must use relational, we have a schema, to, well, we don't really need a schema, but we do need to move data around with Hadoop, to polyglot world where we just query the data where it is. And we only move the data on the fly as we need it. And Drill is the open source tool that allows us to do that. There's also some cloud tools from Google and Amazon that allow you to do it, like Amazon's Athena. And Drill storage providers allow us to configure our sources so that we can drill the data in a variety of formats and from a variety of locations and places. And Drill supports ANSI standard SQL. Views and tables can be created. You can also use common table expressions and window functions and stuff like that. And we saw that Spark has SQL support, and the way that you register, you take your data frame and register it as a temporary view, and then from there, you can use spark.sql to query your data just like it was a table.